A function f is given and the indicated transformations are applied to its graph in the given order. Write the equation for the final transformed graph. So we are to start with the graph of f of x equals x squared. F of x equals x squared would be a parabola with the points 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and on out. And we could draw this parabola. And what we're supposed to do is shift this parabola 2 units to the left. So this should then result in a parabola that would be positioned here, 2 units to the left. Now, our transformations tell us that in order to shift to the left, we would add to x. So whenever we add to x, the graph shifts to the left. Okay, so if that's the case, then the function f of x equals x squared should then be shifted to the left by changing x squared to x plus 2 square. So that then would be the red graph that we drew. And we could verify that. We could plug in some values for x and see what happens for y. Like for instance, if I was to plug negative 2 in for x, the result for y would be 0. If I plug negative 3 in for x, the result for y would be 1. If I plug negative 1 in for x, the result for y would be 1. And that corresponds to these points on the red graph. Now, we are to reflect in the x-axis. And our list of transformations tells us that in order to reflect in the x-axis, we should multiply the function by negative 1. So if we multiply the function by negative 1, the graph is reflected in the x-axis. So our function f of x equals x plus 2 squared should then be multiplied by negative 1. So that means the result would be f of x equals the opposite of x plus 2 squared. The entire function should be multiplied by negative 1. And our entire function here at this point is x plus 2 squared. And so we should multiply that whole thing by a negative. Now, the result of that then would be a graph that is rotated about the x-axis. And it would look like this. And again, we could verify that with some points. If I was to put the same values in for x, minus 2, minus 3, minus 1, if I put negative 2 in for x, I'm going to wind up with 0 for y. If I put negative 3 in for x, now I'm going to get negative 1 for y, because the negative will be applied after the square. If I put negative 1 in for x, I'm going to get negative 1 for y, again because the negative is applied after the square. So these points, negative 2, 0, -3, -1, -1, -1 are all on this graph. So we have given ourselves some confidence that we have this right.